Shocking! Did scientists just create matter from light? Hello everyone, welcome back to our channel Future Focus. When you emerge in the expanse of the cosmos, amid the planets, stars, galaxies, and everything else, an obvious question demands to be answered. Why is something better than nothing? So, let's dive into the video to know the entirety. The difficulty is exacerbated when considering the physical laws that govern our world, which appear to be perfectly symmetrical between memory and antimatter. However, when we examine what's out there, we discover that every single celebrity and galaxy we encounter is 100% memory, with minimal antimatter. Obviously, we exist, just as the stars and galaxies we see. Therefore, it shouldn't produce something with greater memory than antimatter to make the world we are creating conceivable. But how did it come to be? It appears to be impossible. For one thing, given the debris and its interactions with the rest of the cosmos, there is no acknowledged mechanism for antimatter to remember itself as such. The entirety, on the other hand, is formed of memory and no longer of antimatter. It's all in these ways. When antimatter and memory collide in the cosmos, an incredibly powerful burst of force results from particle-antiparticle destruction. To be honest, we think of this as destruction in certain areas, but not in the more practical spherical and hyperliving assets that create memory and antimatter in the same amounts as huge around black holes. Virtual debris is detritus that appears on the internet. When antimatter is remembered in the cosmos, it produces gamma rays with extremely particular frequencies that humans will eventually recognize. The interstellar and intergalactic medium is entirely material. The utter lack of these gamma rays indicates that there is no huge quantity of antimatter trash floating around, as this memory/antimatter signal may indicate. The suggested lifespan in our galaxy's interstellar medium might be in the range of 300 years, which is relatively short in comparison to the age of our universe. This constraint tells us that, at least in the Milky Way, the quantity of antimatter that may mix with the problem under discussion is limited to one component in 1/6 This constraint tells us that, at least in the Milky Way, the quantity of antimatter that may mix with the problem under discussion is limited to one component in 1/6 On a larger scale, such as galaxies and galaxy clusters, the restrictions are less stringent, but they are still extremely powerful. We can observe that even at enormous cosmic scales, more than 99.999% of what exists in our universe is remembering, like us, and is no longer antimatter. Furthermore, scientists say that for the first time, they produced memory from natural smoothness by using an equation from Einstein. According to Albert Einstein's theory, equation E is equal to mc squared. If you destroy enough Lya photons or traces of light in all the others, you must find a way to obtain electrons and their antimatter equivalent, a positron memory. Alternative tests have demonstrated that they are made up of more than one photon, but they were under no need to show the effect as convincingly as possible within the 1-to-1 approach. Several scientists at Brookhaven National Laboratory in New York now believe they have found a solution. RHIC, Relativistic Heavy Ion Collider. At the lab, it enabled the scientists to make observations. They were able to perform observations with the lab's Relativistic Heavy Ion Collider, RHIC, that make specific predictions for the unusual conversion process. Brookhaven lab physicist Zhang Buzhu reported that Breit and Wheeler's work demonstrated that lasers were almost impossible. Nevertheless, the use of lasers at that time was not even possible. However, Breit and Wheeler suggested accelerating heavy ions as a solution. RHIC accelerates ions rather than directly boosting photons. Ions are stripped of their electrons and therefore charged, and they are sent through a huge loop before colliding with each other. Researchers, rather than enhancing photons directly, accelerated ions in a large loop, then threw them in a close collision over all the others. Because ions are charged trash, traveling very near to smooth speed, they bring to them electromagnetic regulation, within which there may be a significant number of digital photons that are no longer highly current, with the ion visiting like a cloud, Zhu stated. The novel description of virtual debris is that it exists more easily than genuine debris since it arises in disruptions within the field as it exists amongst natural debris. They're actual counted counterparts at different hundreds from them. Although digital photons have mass, they are not as many as their massless counterparts. In this experiment, the ions defeated nearly everyone because their clouds of photons traveled so fast that it looked like the digital trash in action, generating an electron-positron pair successfully. So, even though we don't know exactly how, we must have generated more memory than antimatter and beyond the universe. This is made more difficult because, in particle physics, the symmetry between memory and antimatter is much clearer than one might assume. For example, when we produce a quark, we also generate an antiquark, and when we destroy a quark, we also destroy an antiquark. We will also have or waste a lepton, as well as an antilepton of the same family of leptons, and each time of Corleone quark analyses and interaction, collision, or decay, the whole set of quarks and leptons of the net by giving up the response. That's all for the video. Stay tuned for more.